So this is the question of the second numerical problem. At NTP, NTP means normal temperature and pressure, 2.8 liter of oxygen and 19.8 liter of hydrogen were mixed. Calculate the increase in entropy of mixing of ideal gases. Okay, so now in this case, number of moles is not given. Instead of that, the volume of both the gases are provided. So how do we do this? Let's see that. Solution, first of all, volume of oxygen is given. How much? 2.8 liters. 2.8 liter. Now, whenever volume is given, then we can find the value of number of mole of that gas as well. So, number of mole of oxygen, that is N1, can be calculated by just dividing the given volume by 22.4, and whatever value you get, that is the value of the number of moles. That is, in this case, number of mole of oxygen is actually 0.125. Similarly, volume of hydrogen is provided, that is to be how much? Yes, 19.8 liter. Now, to calculate the value of number of mole of hydrogen, that is N2, there will be 19.8 divided by how much? 22.4, right? And if we divide it, we will get 0.875. This is the value of N2. Now, the solution is similar to earlier solution as well. As N1 and N2 are given, then obviously we need to calculate the value of total number of moles, right? So, total number of moles, that is N1 plus N2, will be equal to 0.125 plus 0.875, and if you add them, you will get 1. So, total number of moles of gases is 1 now. Now, we need to calculate the value of mole fraction of both the gases. So, mole fraction of oxygen, that is capital N1, is equal to how much? What is the formula? N1 by N1 plus N2, right? So, N1 is given to be how much? 0.125 divided by 1 is equal to 0.125. Similarly, mole fraction of hydrogen, that is N2, can be calculated by the formula N2 by N1 plus N2. N2 is 0.875 divided by 1 is equal to 0.875. So now we have this much of data. So now we just have to find out the value of entropy of mixing, that is del as M. And what is the formula of this? Yes, you are correct. Minus R ln, N1 ln N1 plus N2 ln N2. So this is the formula that you know already, right? Let's put the values now. Minus 8.314, that is the value of the universal gas constant. N1 is given to be how much? 0.125. 0.125 ln, this capital N1 is also 0.125, plus N2 is given to be 0.875 into ln bracket, in bracket also 0.875. So we get this much, and if you put this on calculator and if you click OK, it's equal to, then you will directly get 3.117 joule per mole per Kelvin. You will always get a positive value over here. Okay, if you get a negative value here in the answer, then obviously your solution is wrong. The entropy of mixing can never be a negative value. It will always be a positive value. So be careful over there. Okay, so if you put this on calculator, you will get this much of value. Now, this is the value, this is the required value of increase in entropy of mixing. This is how we need to solve a question like this. When volume is given, then first of all, we need to calculate the value of number of mole by dividing it by 22.4. And then we need to calculate the mole fraction. Then only we can find the value of entropy of mixing.